I'm very pleased to introduce to you our first keynote speaker for this afternoon, Dr. Naba Barkakati. Dr. Barkakati is the Chief Technologist for the Applied Research and Methods Division at the U.S. Government Accountability Office, GAO. He leads the GAO's efforts to evaluate technologies such as U.S. federal government's software system and enterprise architecture. 네, 자, 지금부터 기조 발표를 시작하겠습니다. 네, 첫 순서로 GAO의 Chief Technologist인 나바요티 바카카티님 박사님을 모시겠습니다. 네, IT를 통한 새로운 비즈니스 모델 창출이라는 주제로 네트워크 인프라와 IT 융합을 활용한 다양한 부분의 기업 경쟁력 강화와 생산성 향상과 같은 혁신적인 솔루션 사례와 향후 BM과 IT 융합의 산업 확산 전망이라는 주제로 30분 동안 발표를 해주시겠습니다. He is currently leading the evaluation of explosive detection system. Please welcome him a big round of applause.
Good afternoon. Well, I hope we had a good lunch, and I'll try to keep myself, within the time, and hopefully exciting enough that you won't have to, feel lethargic after the good lunch. I'm going to spend the next. First of all, let me start by thanking KISDI for inviting me to give this keynote speech, and for giving me the honor to speak to this distinguished audience about IT convergence and IT solutions for new business. I think I hope to provide, I know that we are probably going to, when I finish, you'll probably feel that I'm talking about the similar things as all of our other speakers. But at the same time, I hope there'll be something new from my perspective of working as a chief technologist at the Government Accountability Office, where we look at other US government agencies' adoption of IT technologies and any new trends that come up, including IT convergence, and that gets reflected in those agencies' systems, which we go and look at. So from that perspective, hopefully, I'm going to add some value to this. Well, when you talk about convergence, of course, we are generally referring to what Nicholas Negroponte of Microsoft, MIT's Media Lab long ago had referred to the transformation of atoms to bits, the fact that all information, voice, video, data is coming together in digital form and across networks to devices and PCs to people's hands. And the most common, I guess, manifestation of this convergence is where we see on the hands of the consumers today, the smartphones, where you can go ahead and use the phone for anything from voice calls to taking pictures to video to providing a hotspot, Wi-Fi hotspot for other devices and many other uses. That's where we see the result of this IT convergence that we're going to talk about in a little while. Now, before we talk about the future of IT convergence, I want to focus a little bit on the history of it. I think, they say, those who don't study history are doomed to repeat itself. This is probably a good example where we need to look at what facilitated this convergence over time, and maybe from the lessons of what has gotten us to this point, we can learn and adopt similar ideas for future so that we can keep a good thing going for the future. Now, I would start with this maybe about 1990s, when Sun Microsystems, they had adopted this phrase called the network is the computer. That was used to be in advertisements all the time at the time, And they were, of course, that phrase probably is just the right time to think of as a starting point where you might say, well, convergence, the idea of convergence that had emerged and was beginning to grow. And at that point in time, the conditions were just right for the IT convergence to appear, because the microprocessors, the processing power of the microprocessor from about 1970 onwards has been doubling every 2 years, and that was like the Moore's law that as we know it. We had the network in internet connectivity emerging, and in fact, one of the side issues I want to point out is this network layered model. The the 4-layer simplified model for TCP/IP, where you see that that was a very conceptual breakthrough that was also played a great role in facilitating the network connectivity that we nowadays take for granted, with its every layer with its own protocol, information flowing down from application layer down towards the physical layer, going to other systems, and coming up to applications on another system. So application-to-application connectivity with this network layered model has been one of the major factors as well in that early time to facilitate the development of internet. And of course, as I'll describe a little later, this concept of network layered model comes up in discussions of network neutrality or even virtualization, which is another term you have heard mentioned earlier, and plays a big role in some of the things I'm going to talk about. And then of course, among those protocols that I mentioned, you had HTTP, the hypertext transfer protocol, which is for web transfers between web server and web browser, HTML format. There's a whole host of other things that are behind the scenes that enabled us to have all the connectivity that we have seen since the days of mid-1990s. Now, sorry, I think, oh yeah, I forgot. I was going to also bring up one more item. One element, at least in the United States, that was a facilitator for the convergence was the US Telecommunications Act of 1996. The reason I bring this up is, of course, before this act was passed, for about 64 years, there was no change in the US Telecom Regulations, and it was designed for voice telephony in old times. When they had done this law, passed this law in 1996, the idea was to encourage competition among all types of, primarily in the same mode of communication, like telephony, was local, long distance. It was designed for competition in those areas. And it also gave a task to the Federal Communications Commission, which is in the United States, that's an agency that regulates spectrum and telecommunications regulations. They were tasked to promote broadband adoption in the United States. So they did that by classifying the internet connectivity as an information service, which required less regulation. They reduced the regulation on that, and that was a big facilitator, in fact. Now, their goal was to promote, as I said, voice over switched network, switched circuit network, and local and long distance. But what resulted after this act was more of a intermodal competition between different modes of communication, among wired versus wireless, and also voice over IP over wireline and wireless communication, IPTV and cable TV. And so in the end result was we had a bundled services that emerged. From my own personal experience, within the last maybe 5-10 years, we got these bundles of services that were offered by different companies. Maybe someone who has connectivity to your home through cable television, they offer voice, video, internet, usually, as a bundle, offered by telecom companies like Verizon or cable companies like Comcast, and that really promoted to the connectivity to the home greatly. With all these factors coming into play, of course, what we saw was the emergence of this internet business model. Now there was connectivity to people and businesses, and there were businesses who wanted to take advantage of that to do business, in terms of selling things, for instance, ideally in the beginning, online commerce, Amazon.com. These are some of the household names, probably worldwide, mostly at least in the United States. Auction, like online auction, eBay, search engines, Yahoo, Google. Now more recently, the social networking, Facebook, Twitter, etc. So these have, of course, caused businesses to look at the internet as, some kind of internet business strategy as a routine matter of their existence now. And for instance, most businesses today would always consider having a website, maybe online commerce of some sort for selling things. They would probably have presence on Facebook, Twitter, other social media. They would be taking into account like search engine optimization to make sure their website or their company comes up first when you search for the right terms, on the web search like Google or Yahoo. So those things are taken on as a very routine matter of business strategy for any business that's working today. But now, moving on to the core area of the discussion for this last 15-20 minutes of my time, it's the focus on the convergence of IT together with the network infrastructure. And by network infrastructure, we mean the internet, internet infrastructure. What we see is that that's giving rise to what we call cloud computing. And virtualization plays a key role there too. Of course, what is happening is data centers that are built in the core of the internet with good connectivity, large-scale data centers can now offer, if you have connectivity to them, you are easily able to access their services, the computing power, in terms of either running applications or just renting the facility for storage or for developing application. I'll talk a little more about it in a little bit of time. But as I mentioned earlier, one element that has played a key role is this virtualization concept. And this also, you'll see, it's like a similar layered model idea. You have the bottommost layer where you have the physical hardware devices of a server, the CPU, memory, disk, etc., network card. Above it, you have a virtual layer, abstract layer. And then above that, you can have actually operating systems, different operating systems, running in different machines that are virtual machines, each with its complete, virtual hardware, operating system, applications. And this is kind of the crux of also one of the, reasons why we see the growth in cloud computing, because now you can suddenly have maybe one powerful server can support maybe 60, 20, 30, depending on how it's configured, multiple numbers of virtual machines. And you can rent your, one of those virtual machines or multiple of those to do computing if you need to. So that's one of the facilitators as well, the virtualization of cloud computing. Now, as far as we had looked in our Government Accountability Office, we had looked at the cloud computing adoption by US government and, of course, government agencies. And we have an organization called NIST, which does standards, and they had defined some concepts for cloud computing. The two elements to remember. One is the service model and how the service is purchased from the service provider. The second one is the deployment model, how the cloud is built and organized and implemented. So I'll cover both. First one, the service model. If you look at the line I draw here, see the three layers here: infrastructure, platform, and software. Infrastructure is the hardware, the servers, maybe the virtual machines. The platform level would be like an operating system level, and maybe you're buying Linux operating system level with programming languages that you choose. And above that is application level. At that point, you're buying basically you're trying to get time to use applications. Like trying to, for instance, even though the concept of cloud computing sounds new, well, we had Salesforce.com, who has this customer relationship management application where you can rent time and buy, to use it. They were offering it as a software as a service since like 2007, I think. So if you draw the line at the infrastructure level, you get infrastructure as a service. If you draw the line at the platform level, one level up, you get platform as a service. And if you take at the level of the software, it's software as a service or application as a, application service provider or things like that, other names that come up. So depending on what you need, depending on your business type, you can select the level of kind of service that you want to buy from a provider. And in fact, by now, if you just search, you'll find Amazon Web Service. Amazon has the Elastic Computing Cloud or something, E2C, I think is the name. They even have the pricing there. You can buy a Windows machine. You can buy. You're buying the machine on the web, of course, and you can use it from your business, as if it's your own computer. But they have pricing models and all provided now, and it's kind of offered on the internet already. The next one, the deployment model, is just focuses on, because people have concerns, right? That if it is cloud, then maybe it's like out there somewhere. How would I control it? You might have an issue with the data where it's residing. So there is actually concept of private cloud. If you have a large organization, you could still, there are actually benefits, even though it sounds like, why would I do a private cloud if I'm running my own computing facility? But there are benefits that come with it, because it's kind of standardized the way the whole cloud computing idea has evolved. It may be still a good idea to have a private cloud for your own organization. Or you can have community cloud, which is multiple similar businesses could group together to share something. Like it's kind of shared among only the members. And then the public cloud, of course, is the internet-based, the one that I'm talking about, Amazon's web services or E2C, things like that. And then the last one, just for the sake of completeness, it's a hybrid cloud. Maybe you have a private cloud working with a public cloud, that sort of thing. So those are the two things. We got the service model, you got the deployment models. Now, Just as a segue, just to mention some of the things we have seen, because I mentioned we looked at the government's adoption of cloud computing. So there are actually a lot of work going on in various US government agencies in adopting cloud computing, because they see it as a an easy way to quickly ramp up capability. We have had a lot of problems in building complete IT solutions from scratch, like tax system or even air traffic control system, things like that. I mean, our organization looks at that and we found a lot of problems, and that has been going on for a long time. But this is seen as maybe an easier way to accomplish the goal of getting the systems up and running quicker. The NASA, for instance, has something which is for scientific computing and web-based applications that they call Nebula, which is just a infrastructure as a service, meaning whole computing system, multiple servers and network and everything is packaged into a container, and you can deploy it for some agency to use it. And then DoD, Department of Defense, has this rapid access computing environment, which is actually a platform as a service. They provide a development facility that the government agencies can rent. This will have to be DoD. They can rent time on it to build applications without having to go through procurement and the process to buy their own computers and all, making it easier. And then actually we had in the summertime, with our stimulus that was going on in the United States, there was a program to trade in your old car for a new one, more fuel efficient one, and get some money from that, get some refund, I think rebate, So that program had to be started very quickly. So the Department of Transportation had actually got public cloud, on the public cloud rented facility for the web server and all that, to quickly deploy that website and get it going. So that was one example. And of course, Google apps for government, Google advertises applications for US government, state and local and federal, where they promise that the data is going to be stored on servers in the continental United States, and it'll be separate from the public. So it's like to give assurance to government that they can use it. So there are a lot of things like that are being considered by agencies because they're seeing it as a new way of maybe getting systems up and running quickly. Now, just to segue from that to, because our topic is focused on IT solutions for businesses, I would just say that at least at the minimum, even for a small business around the world, I think in fact I have run into a lot of examples. Like some nonprofits I was working with, and they were doing all the email and the all the applications for Google Apps, Google Apps and Google Mail. That would be a software as a service. You can buy for a small fee all the email accounts and buy the facility to do word processing on their server, and the document is stored there. That model, software as a service, could be very efficient and easy way for businesses to take advantage of the cloud computing that's coming up now. And since there are many who are offering this already, some of the benefits, just to kind of reiterate and make the point, of course, the applications are going to be on the cloud, so they're always, you only have to sign up and you can immediately begin to use it. It's just like buying a product, right? just pay the fee, sign up, and you can log in and begin to use Google Mail or Google Apps. The other applications are going to be the data that if you're writing documents on Google Docs, well, they're stored in a server on the internet, so you can access them from anywhere, from home or from office or on the go, if any device that connects to the internet. You could get to this document and work on it. So that's somewhat of a beneficial thing because you can work from anywhere and it's always there. And then you do get these data centers do have they're designed to be fault tolerance, redundancy, backup power, all those things are there. So, and then of course you're sharing the cost of the whole data center among all the users, and applications development cost, etc., is also shared. So you get the economies of scale, and you get the fault tolerance and the redundancy, just because you may not have the ability to do that on your own with your own resources, but you can take advantage of it just for a small fee. And in fact, that flexibility of signing on and using it, of course, gives you also the flexibility to drop it when you don't need it. So you can actually grow or make more use or less use depending on the business's need. And finally, I guess the paying for the service as you go, you don't have to tie up a lot of money in buying your own servers and systems and setting up your own infrastructure, so to speak. And instead you can use the money for other business reasons. So there are many good reasons for considering it, of course. So whether it's a private cloud or on the internet, that definitely is one new emerging trend that should be beneficial to businesses as to find new IT solutions, for their business. Now, not everything is rosy in the cloud computing area. There are some risks that people point out. One was the potential for locking in by a vendor. I mean, if you buy, depending on what level you're buying, if you're getting an application, I mean, the data is residing there. Can you move it to another, can you move that data to another software or not? That can be an issue. Or if it's a platform, if you develop using a programming language or maybe application programming interface they give you, that's from that vendor, maybe you cannot take the application to another place because that's a different, you need to write it in different API. So that kind of things can happen, but I would say that concern is really not any different from if you bought your own, decided to use Linux or Windows or whatever platform you pick, and you decided to write your application in one language or another. It's a similar situation. If you want to move now from Windows to Linux, you might have a problem also, similar kind of situation, right? So that may not be a big issue. The other bigger issue we found from talking to the government agencies was their concern about the security. Although they were positive also, they had positive and negative. The positive aspect was they thought that these data centers, they usually are very good they have a lot of staff, people there. They have automated tools, and they can actually quickly patch the system, for instance. If there's a security problem, they can update the system. They could do those things more easily than oftentimes private businesses or, for instance, any government agency. So in that sense, that was a positive point. But they also saw the risk because the vendor who is giving you the service promises to give their security and whether you can depend on them or not. This is like a shared responsibility. And of course, also, we had, like I said there, like 22 of 24 agencies saw some risk. And one reason was there is a law in the United States, one of the government agencies have to follow this law. It's called FISMA. It's like basically Federal Information Security Management Act, something, from 2002. So that requires them to certify that the system is secure, but they're not sure how to certify that the system is secure if it's not run by them. So that's where we have a situation where there's some guidance needed. But this is primarily, of course, for the United States side. But I assume that similar kind of concern might arise here as well, if you're going to go to cloud computing. Now, I mentioned all this about the taking advantage of cloud computing those are like the server side implications, on the back-end system where your processors are, where your applications are. What I mean by this particular point is that there is implication on the client side, all the things we talked about, how everybody with smartphones or any internet-connected device or PC or anything can now make use of the services. Well, that implies that, if you're a business, you should think about your customers or your own internal users being able to access your services that are on the cloud, which are going to be easily accessible if you provide easier way to access them. And what I mean by that is those applications that you see, they're the smartphone apps, for instance. Maybe your business wants to promote itself. You might consider having smartphone app for your business for different platforms so that they can get to your back-end cloud service. That would be probably a good strategy to follow for any business. Finally, I think I have only a few more minutes left. I'll just quickly switch to a little bit on the telecom regulations that are coming up, or at least being talked about in the United States, and in the light of the convergence that's emerging. Not that there has been any legislation passed, but many people in the Congress are talking about the need for more regulation because they see that the bundles of service have emerged, right? And they're not regulating them. Sometimes they get worried that maybe it's not being done right or whatever. So this debate has been going on now that maybe new regulations are needed beyond that 1996 Act to regulate these services. And of course, there are many camps, right? One side might want regulation, one doesn't want. So that's debate going on. And the net neutrality, which we had Tim Jennings ask the question of the panel previously, that happens to be also something that comes up. And just like I think we had someone from Google, right? Ted, he replied about net neutrality. In that debate, I just want to point out that this network layered model is often brought up in discussing that, saying that, well, network neutrality implies that whatever is going on in this physical layer, the bits that are going around, should not be affected by what application they belong to. you just simply let them go. It's like a road on which any car can go kind of thing, as long as you observe some posted rules and protocols. So that argument is brought up a lot of times, that if you do not allow network neutrality, the good thing that you got from this nice layered model would be violated. Now, I don't know whether it's true or not. I'm not going to try to comment on whether it's one way or other, but that debate comes up quite a bit. Now, in terms of specific activities, our Federal Communications Commission actually was taking action against Comcast, one of the cable company, that was trying to control control the flow of traffic from a BitTorrent. You might know the name BitTorrent, which is a peer-to-peer network. They thought that it was using too much bandwidth, so they were controlling, they're throttling that, transfer. And FCC took some action against Comcast in 2008, and then the Comcast went to the courts, and the courts eventually in 2010, recently in April, they ruled that FCC has no standing to take any action against Comcast. So some people thought that was a signal from the court that network neutrality is not needed. But then in August 2010, just recently again in summer, Google and Verizon actually proposed a framework for legislators saying that that basically gives us network neutrality for wired broadband or wired internet. But they were saying that wireless should be exempt because it's changing too fast. So again, the debate is going on. So nothing is really resolved there. I just simply point out as something that will affect, obviously, in the United States, and maybe it would affect if you have debates like this out here as well. And sometimes some of these things can affect everybody, because if they're controlling some traffic there, well, it's interconnectivity everywhere, so everyone gets affected. On the other point I wanted to make was FCC also takes care of the spectrum. And of course, we talked a lot about how we will get benefits from connectivity, but the broadband on the wireless side requires spectrum to provide the broadband. And at least in the United States, they have problem finding big chunks of spectrum to do that. And so there has been some move to, I think we had in our stimulus act, the act that was giving a lot of money to do various infrastructure, there was a requirement for FCC to develop a national broadband plan. And they did develop a plan which is sort of talks about goals, and the goals are all very good and laudable goals to find spectrum. For instance, they want to get 100 megabit, which you might have in Korea already, but 100 megabytes to 100 million homes by 2010. That was one of the goals. They also want to find 500 megahertz of spectrum, free up 500 megahertz of spectrum for use in wireless broadband connections and all. They also look into requirement for broadband connectivity for smart grid, which we saw in previous presentation examples. So those have been activities that are going on. One recent development was FCC in September 24th of this year. They did approve the use of some, they called it white space, I guess, between TV stations, because all of our television now moved to, from analog to digital, and they have kind of freed up some, or they're saying that they can, companies can use this white space for super Wi-Fi. I mean, Wi-Fi maybe longer range, but the whole thing is very early now, and nothing has been implemented yet. And I think, we'll see where it goes also. So I didn't want to take too much time. I hope I'll be within the 30 minutes limit. I wanted to end with this slide, actually, because we always go to government agencies, and we always say that progress has been made, but much remains to be done. And there's a positive thing here as well. This is actually one of our report was comparing all the broadband adoption in different countries. And Korea, of course, well, in OECD ranking, it comes like 7th, but they have different measure or whatever. And then there's another ranking where it comes up number 1, the household penetration or something. Penetration in the household is almost 100% kind of number. So, of course, as you can see, I mean, it's great here, but it's not the same. Even in the United States, it's way down, and many other parts of the world, it hasn't gone there yet. So obviously, even in this, even though we are very positive and forward-looking and how things are going to be great in the future, but I feel like we have to be somewhat realistic and understand that it's not there yet. I mean, we still have a long way to go, and I guess the nice thing is I assume the journey will continue and we'll, be able to get there someday. I think I would probably just stop with that. I hope I gave you a little bit of insight into cloud computing and virtualization and good things about the network layered model and how all of this has benefited us so far. And it remains to be seen from now on whether we continue to get the benefits or not. depending on what we do, obviously it'll affect, and we'll have to see where it goes. Thank you.
Thank you for the very insightful speech.